Hey y'all, Data Guy here. And today I have a video for you that is kind of a follow-up to a comment I got in my last video on NoSQL databases, where someone wanted to know, wanted to know the comparisons between, when should I use a NoSQL database versus when is a more traditional SQL database going to be more appropriate for your use case. So what I'm going to try to do in this video is basically lay out, hey, this is what a SQL database looks like, this is what a NoSQL database looks like, what their pros and cons are, and then at the end I'm going to, as I like to do, develop a framework for kind of helping you decide, hey, which database type is right for my specific use case, because it's not a blanket one-size-fits-all approach. Sometimes a NoSQL database is going to be better than a SQL database for a particular use case, and vice versa. So it's really important to, for every instance where you're deciding on a database to use for a project, to make sure you're using the correct type. And so that's what we're going to try to do today. So to start off, I want to just quick dive into SQL databases, and then we'll go into NoSQL databases after. And so what you're seeing up on screen is a typical SQL database, what it might look like. Very kind of what you think of when you first think of a database, different tables linked together through defined pathways. You have things like foreign and primary keys linking, order status or staff ID from the staff list to an order table. And it's almost like a web of complex relationships that you define in kind of a structured way before then, moving the data, storing it in that structured way so that you can use it for whatever use case you're looking to do. And that's where the structure kind of can help define your database and optimize it for a particular use case. You can make it really easy to do certain queries, and maybe it makes some other queries harder, but you're not going to be doing those queries. So that's why you chose this schema. And so schema choice and modeling is a lot of the work here, and then also you have to clean and manipulate your data so that can be uploaded directly into the database in the format that the database requires. So important thing to note there. And this methodology is really based around the ACID principles and ensuring data integrity through those principles. So if you're not familiar with ACID, I'm not talking about LSD, I'm talking about atomicity, consistency, isolation, and durability. So these are kind of the main principles that SQL databases are built on top of, and the reason why they're so strict and so prescriptive and you have to build these structures because it wants to make sure that every database, every table is atomic, it's consistent, it's isolated, and it's durable. And so popular examples of a SQL type database, is something like MySQL, PostgreSQL, and Oracle databases are, the grandfather in the room. And so some of the benefits that this really structured approach can give you are, number one, structured data. SQL databases really excel in handling very tightly structured data with defined relationships, and then that offers those powerful query capabilities that I mentioned earlier. It also is ACID compliance, and ensure that those ACID properties ensure reliable transaction management, data integrity, and these are really critical for applications that need to have consistent data states, such as financial systems, patient data, anything where the accuracy and the consistency of the data can get you into real trouble if it's wrong. And then also a mature ecosystem. The SQL databases have been around for decades now, and there's extensive documentation, well-established standards, and really a large pool of experienced developers that you can kind of build off the back of. Hire, most people are going to know SQL database if they're working in any kind of data or engineering practices. It just is kind of the bog standard, and has been for a long period of time. However, on the cons side of things, schema rigidity. Having this really structured, really defined schema can also be annoying. It can be really annoying when you're like, okay, now I got to manipulate this really dirty, unclean data just so I can upload it into my database, and it requires a lot of extra pre-processing work when maybe you don't need that clean of data. Maybe you're just doing some basic customer analysis, and you can kind of do an ad hoc query on that raw data in more of a data lake style. Also scalability. So vertical scaling is really easy. Just increasing the size of the server is really easy to do. However, horizontal scaling, adding additional databases to a data warehouse is much more difficult, because then when you add a new database, you then need to define how everything within that database that was horizontally added can interact with and talk to other horizontal databases within the same warehouse. And then finally, the complexity of SQL queries, and needing to know really all the rules around schema design and making sure you use star versus snowflake versus whatever schema. It's definitely something that will only become more, it's like the opposite of economies of scale. It's going to become more complex the larger your data sets are. And you can see even this relatively simple example, there are quite a few different connections here, and knowing how to make them the right way, it's a lot of trial and error. It's a lot of, hit pound and sand and trying to figure out, hey, does this actually work the way I want it to? So those are kind of some of the downsides of SQL databases. And now, time to look at NoSQL databases. So now, in sharp contrast to SQL databases, NoSQL databases are designed to store, retrieve, and manage data without a fixed schema, which is a much more flexible approach to data management. And as you can see here, what that means is not every single item within your NoSQL database actually needs to have the same amount of attributes. They just need to have a primary key that I can reference that item with. So you can see here in this NoSQL database, we have books, we have albums, we have tracks, we have movies, and they all have different IDs that are linking them to different types of objects, and within each of those objects, they'll have different attributes. And this product ID, the 1, 2, 3, 4, 5, just kind of gives you an easy way to say, hey, this is the first entry, second entry, et cetera, et cetera. But as you can, might imagine, this isn't the same kind of rigid table structure where everything needs to be in that defined format. You can just kind of ingest data as individual object types. So, a book would be an object that I'm ingesting, an album would be a different object. And this allows you to just, again, be more flexible in your data management. They're ideal for unstructured data where, this data can change over time, but I still want to capture all that old data and can efficiently handle large volumes of data at high speed because you don't have that kind of slowdown time when, hey, this data is created, now I need to process it before it actually goes into my backend database. You can just pipe that data directly back into a NoSQL database because you don't need to do that kind of data cleansing step. And so some popular NoSQL databases, and they're kind of actually categorized into 4 main types. There's document, which is Mongo, CouchDB, key value, which is Redis or DynamoDB, wide column, which is Cassandra or HBase, and then graph, which is Neo4j or Amazon Neptune. And if you want some breakdown like with the different types, the different providers, go check out my previous video on what type of NoSQL database might be right for you. But some of the pros of a NoSQL database. So now, going into the benefits of a NoSQL database, number one, schema flexibility. You can accommodate any kind of change in data structure, well, not any kind, not extreme changes, but most changes in the data structure without significant modifications, which just enables faster iteration and, of course, development because you don't have to massage that data, manipulate it into some defined type that might not fit that type of data really well. It's also very scalable. Unlike SQL databases, NoSQL databases are designed to scale out horizontally, constantly adding more compute nodes in a horizontal manner, which makes them suitable for applications with really large and distributed data sets. And then finally, high performance. Because they're optimized for specific data models, they provide efficient storage and retrieval mechanisms that can outperform SQL databases in most cases. So it makes it much easier to query your data, even though it's not in that kind of rigid structure that a schema database would demand. Now, on the downsides, number one, so you have ACID for SQL databases, but NoSQL databases mostly adhere to BASE, which is basically available, soft state, eventual consistency, which means you might not have immediate consistency over all of your compute nodes. So if data consistency is a really big driver for your business, if it's a really big issue for your project, a NoSQL database might not work well for you because you need to kind of accept that, hey, maybe all my data isn't accurate at this point in time, but it will eventually be. And then on the flip side, they just don't support ACID transactions. They might support database transactions, but they're not going to have the same level of transactional integrity that SQL databases offer through those ACID properties. And then finally, complexity in data aggregation. The lack of a standard query language can make data aggregation and complex transactions more challenging to implement because there isn't just a standard, easy-to-use SQL to write queries in. Every provider typically has kind of their own language that they ask you to write queries in, and you have to kind of get up on that learning curve to figure out, hey, how do I interact with this new NoSQL database? So those are the 2 types. Now, let's get into the framework and compare to figure out which one is right for you. So when you're deciding between NoSQL or SQL database, it really is going to hinge, again, on the specific requirements of your application, including your data structure, your consistency, your reliability needs. And so what I've done is kind of develop a little bit of a framework to help you decide this. And so the first step of that is data structure and integrity. If your application requires really strict data integrity and relationships between different entities in a defined way, then a SQL database is probably going to be preferable due to its ACID compliance and also its relational data model. However, for applications that are handling really large volumes of data that require horizontal scaling, a NoSQL database may be more suitable due to its flexibility and distributed architecture under the kind of guideline of scalability and performance. A NoSQL database will typically, just out of the box, be quicker than a SQL database. But obviously, you can optimize in either way to make that not true, but just kind of in general. Then third, development speed and flexibility. Projects that really require rapid development and frequent modifications to your data model might benefit from a schema-less nature of a NoSQL database, because then you don't have to constantly be updating your schema, constantly changing it, just to keep pace with your business needs. And so that's where SQL database might just introduce a lot of additional friction that you don't necessarily want or see the benefit of. Then fourth, we have query complexity. If really complex join-heavy queries are a core component of your application or use case, SQL database's advanced query capabilities are probably going to be the better option for you in that instance. And then finally, fifth, ecosystem expertise. You should really look at the availability of skills and tools within your the team or community that you're going to be using to influence this decision. Don't just say, hey, if you have a team of really crack SQL engineers, don't make them go and learn NoSQL. And vice versa. If you have a lot of really experienced NoSQL database engineers, don't make them all convert over to SQL. Leverage whatever your team is best at for your use case. Don't just say, oh, well, George said this, so I got to do that. No, it is very much, it's kind of a gray area there. You don't want to introduce a lot of additional friction just because you think, hey, I might get some benefit out of this. But that's, again, up to your decision. And so in kind of conclusion, both SQL and NoSQL databases have distinct advantages and trade-offs, which makes them suited to different types of applications. So SQL databases, really unparalleled data integrity, query power for structured data, versus NoSQL, which provides really easy scalability and flexibility for unstructured data and rapidly evolving applications. And so can't say that's enough. Choice between them should just be guided by your specific project requirements, those factors like data consistency, scalability, and the nature of the data that's being managed, and understanding the strengths and limitations of these, hopefully, has helped you to make that right decision for your particular use case. So I hope you enjoyed this video. I hope this has helped you, and I hope you have a great rest of your day. Data Guy out.